teach you some about mole-to-mole relationships. Now, there is another video that I have about mole relationships, and that's mole-to-mass relationships. Make sure you watch that one before you watch this one. That gives a little bit of an introduction to the concept of the mole. Mole-to-mole relationships. So in the previous video I spoke to you about what the mole is. It's a chemistry definition for amount of a substance. But going from moles of one thing to moles of another is particularly important when you're talking about balancing chemical equations and doing chemical calculations involving different species. So for example, if you have 1 mole of propane, now propane happens to be C3H8. So if I say we've got 1 mole of propane, it's important that you can understand, if I have 1 mole of propane, how many moles of carbon do I have in that propane? Well, I've got 3, because of the 3 right there. So 3 moles of carbon. And in 1 mole of propane, I've also got 8 moles of hydrogen. Alright? So if a question says how many moles of carbon are present in 0.25 moles of propane, what we need is a conversion factor relating propane and carbon, which is what we actually have here. So if we have 0.25 moles of propane, we need a conversion factor here, and we need to end up with an answer of moles of carbon. Of course, that means for our units here, we've got to have moles of propane on the bottom, so they can cancel out, and then moles of carbon on the top. So our conversion factor here, or our mole ratio at least, shows 1 mole of propane gives us 3 moles of carbon. So therefore, when we cancel that out, 0.25 times 3 is 0.75 moles of carbon. If we had to do the same thing for moles of hydrogen, it'd simply be 0.25 moles of propane and 1 mole of propane on the bottom, and then 8 moles of hydrogen on the top. So 8 times 0.25 is 2. That'll give 2 moles of hydrogen. Now, if we had something like this that said, given a balanced equation like this, the reaction of sodium with oxygen gas to form sodium oxide, there are 3 relationships here to understand. You can relate sodium to oxygen, sodium to sodium oxide, or oxygen to sodium oxide. It doesn't really matter which. The thing that's important is to remember, if a question asks you, for example, how many moles of sodium oxide are formed when 12.5 moles of sodium react, that tells you you're looking for the relationship between sodium and sodium oxide. You're not bothered about the oxygen because the question's not asking you about it, so forget about it. Unless the equation's not balanced, you can forget about that. So this tells us for every 4 moles of sodium, we get 2 moles of sodium oxide out. The question then asks how many moles of sodium oxide will form if 12.5 moles of sodium react. So therefore we know to start with 12.5 moles of sodium, and we also know then if we're asked to form a number of moles of sodium oxide, then we need a conversion factor that involves sodium and sodium oxide, and because sodium oxide is going to be in the answer, that needs to be on the top. And also because the moles of sodium we want to get rid of, that's got to go on the bottom. From our balanced equation here, we can see that for every 4 moles of sodium that we put in, we get out 2 moles of sodium oxide. 2 divided by 4 is the same thing as 1 divided by 2, which means 12.5. Well, 12.5 times 2 divided by 4 is the same thing as dividing that by 2. So we get 6.25 moles of sodium oxide. Alright? And that's how we do that. All you need is the mole ratio from the balanced equation. So you've always got to make sure your equation's balanced, and then the number of moles that you started with. Alright, one more. How many moles of oxygen in 3.7 times 10 to the negative 3 moles of cobalt 3 sulfate this is? So we know we're going to be starting with 3.75 times 10 to the negative 3 moles of cobalt-3 sulfate. So that's what we're starting with. But we want to end up with a number of moles of oxygen. So we need a ratio, a relationship between number of moles of this guy and number of moles of oxygen. So if we write out 1 mole of cobalt-3 sulfate, and I'm writing this out simply so we can come up with a conversion factor that we can then put here. So that should be a big, oh no, it's a small O. Now this is going to be moles of O over here. Now, all we've got to do is look at our numbers here and make sure that we can figure this out. Notice there's 3 sulfates here. Each sulfate has 4 oxygens in it. But we don't have 1 sulfate, we've got 3 of them. So therefore the number of sulfates is 4 times 3, which overall is 12. So that means then if we have 1 mole of cobalt-3 sulfate in there are 12 moles of oxygen. So when we write out our conversion factor, can everybody see that we've got to have 12 moles of oxygen on the top for every 1 mole of cobalt-3 sulfate. So 3.75 times 10 to the negative 3 times 12. I should have done this before I started this bloody video, but here we go. 3.75. I'm typing this into my calculator as we talk. La-di-da-di-da-di-da. Times 12 gives us 0.045 moles of oxygen. Now there's 3 significant figures here, so I'm going to show 3 here as well. That's 3 significant figures. You can see this number is a lot bigger than this one, but then it should be because you multiplied it by 12 to get to the answer. So that is mole-to-mole relationships. If you can get this down, and you can understand the mole-to-mass relationships in the other video, you will be set for this material. Alright? And a knowledge of this basic material is really important for what we talk about later on, which is applications of, more complicated applications of this. So make sure that you got this stuff down. Alright?